At the center of the study of trigonometry is the study of angles. This video will talk about how radian measure works, but first we need to talk about the different parts of the angle. So this one over here is called the initial ray. This one over here is called the termination ray. And where the two angles meet over here is called the vertex. Now, the initial ray over here is drawn in what's called the standard position, where it's parallel to the x-axis. And this would actually, if I was drawing the x and y axis, this would actually be the origin where the vertex is. Now, when we're starting from the standard position here, and I go this way, the angle that we're measuring is in here, shading it in, looks like this here. And this is starting from the standard position. And if we were talking about this angle theta here being about 315 degrees, we would be looking at the angle that goes around here. And then one final piece before we move on to radian measure. If I'm talking about this angle over here, and that's 315 degrees, there's another angle from here, which is talking about this angle, which wouldn't be shaded in, and this could be, say, minus 45 degrees, and this would be known as a coterminal angle. Now, in working with radian measure, the first position that we should know about is if we're starting from the standard position and we go all the way around, this here is considered 2 pi. So theta here, this is 2 pi. And if we went halfway around, theta would be equal to pi. So 360 degrees is equal to 2 pi. 180 degrees, which is what we have here in the picture, is equal to pi. So from here, we should be able to come up with the formula that to go from degrees to radians, uh, 1 degree is equal to pi over 180. So then using that, where 1 degree equals pi over 180. So let's try a few examples. So let's say that we had 40 degrees. To do 40 degrees, we would have 40 times pi over 180. And then we'll reduce. So both are divisible by 10. And what we get is 2 pi over 9 radians. Let's try another. Let's try negative 270 degrees. We would again have pi over 180. So we'll reduce. 90 goes into here 2, 90 goes into here 3. So what we would get is minus 3 pi over 2. Let's say that we had 90 degrees. We would have 90 times pi over 180. And then when we reduce, we'll get pi over 2. And in this last example, 90 degrees is pi over 2, so we would be talking about this area of the circle over here. Let's try a few examples where we're converting from radians back to degrees. So here we have the conversion rate from radians back to degrees. 1 radian equals 180 degrees over pi. First, I'll do these 4, and then I'll list another 4 and allow you to pause the video, try them on your own, and then check your answers against what I have on the screen. Pi over 2 times 180 over pi. Now, the first thing that we see is that pi is an actual value. It's not a variable, so pi goes into itself once, pi goes into itself once. Then we get 2 goes into itself once and 2 goes into 180 90 times. So this becomes 90 degrees. On this next one, we're going to have 2 pi. We need it as a fraction times 180 over pi. First, we cross simplify. Pi goes into itself 1 and 1. And then we have 1's on the bottom and 2 times 180 on top, which is 360. So this one is 360 degrees. On the next one, we have minus pi over 4. We're multiplying by 180 over pi. And when we simplify, and 4 goes into itself once, and 4 goes into 180 45 times. This one, we have a minus sign here, so we bring that over, and that's minus 45 degrees. And then this next one, we have 9 pi over 2. We're multiplying by 180 over pi. We simplify the pi, goes into itself 1 and 1. 2 goes into itself once and into 180 90 times. And this one turns out, if you use calculator, 9 times 9 is 81 plus the 0. This is 810 degrees. Let me put up a few for you to try on your own. So at this point, I encourage you to pause the video and convert these degree measurements into radians and convert these radians into degrees. So for the first one, we have 30. And if you need to see it as a fraction, you can put it as 30 over 1 times pi over 180. So 30 goes into itself once, and 30 goes into 180 6 times, so we get pi over 6. For 60, we have 60 over 1 times pi over 180. We reduce, 60 goes into itself once and into 180 3 times, so this one is pi over 3. And for this last one, you have 120 over 1 times pi over 180. And 120, so 40 goes into that 30 times. 40 doesn't go into here. So 30 goes into this 4 times, and 30 goes into here 6 times. This reduces further to 2 and 3. So we would get 2 pi over 3. And then over here, even though the answers are over here, we're still going to run mechanically through these to convert the radians back to degrees. So you have pi over 3 times 180 over pi. And what you get when you reduce is 60 degrees for the first one. And the second one, it's going to be pi over 6 times 180 over pi. And when you reduce, you get 30 degrees.